In modern naval combat, the line between survival and total disaster, it's measured in seconds. You've got anti-ship missiles that are screaming along at supersonic speeds, crossing a mile in less than 5 seconds. That's way too fast for any human to react. So what do you do when a 1-ton missile is headed right for you? Well, you put your faith in a robot. Let's see how this thing works. Say hello to the Phalanx Close-In Weapon System, or CIWS for short. I mean, you can see why sailors almost immediately started calling it R2-D2, right? It's got that iconic dome and compact body. But make no mistake, this isn't some friendly little movie droid. This is a ship's last desperate line of defense. All right, so here's what we're going to get into. We'll start with why this system was even needed in the first place. Then we're going to look under the hood at its brilliant engineering. We'll see how it's had to evolve, check out its pretty controversial combat record, and finally really understand its legacy as a guardian on both land and sea. Okay, first up, let's really understand the problem here. Modern warships are these incredible floating fortresses, packed with long-range firepower, but they're also surprisingly vulnerable up close, especially to these missiles that skim just feet above the waves, flying faster than a speeding bullet. So by the 1970s, the US Navy knew it had a huge problem on its hands. A sea-skimming missile could just pop over the horizon and hit them in less than a minute. They absolutely needed a system that could find, track, and kill that threat with zero human input. And this ship you see here, the USS King, that's where they tested the very first prototype, way back in 1973. And that, right there, is what a CIWS really is. It is the final barrier. It's for when your long-range missiles have missed, when your electronic jamming has failed. The CIWS is the last thing standing between your ship and an incoming weapon. So the bottom line is, it has to work every single time. So, how does this robot guardian actually do its job? Let's pop the hood and see what makes this thing tick. The Phalanx is just this marvel of self-contained engineering. It's got its own powerful Ku-band radar, which is perfect for getting a super precise picture of small, fast-moving targets. Its computer is the brain, a lightning-fast mount is the muscle, and of course, the heart of the system, a 20mm M61 Vulcan cannon. Yeah, the same brutal gun you'd find on a fighter jet. Now, this is where it gets really cool. This is basically the system's thought process. Okay, so first, its search radar is constantly scanning the sky. The computer then sifts through that data, looking for valid threats. Is it going fast enough? Is it heading for us? If the answer is yes, it locks on with its tracking radar. And once that missile gets to about a mile away, the system just opens fire, all by itself. And when I say opens fire, I mean it unleashes an absolutely furious storm of 20mm shells. The modern versions fire at a rate of 4,500 rounds a minute. Just try to wrap your head around that. That's 75 rounds every single second. But here's the secret sauce, the key to its incredible accuracy. It's something called a closed-loop spotting system. See, the Phalanx's radar isn't just tracking the missile, it's also tracking its own bullets as they fly through the air. So if the rounds are a little off, the computer instantly corrects the aim, literally walking the stream of fire right onto the target to guarantee a hit. It's genius. But of course, the threats of the Cold War aren't the threats of today. The battlefield changes. So the Phalanx has had to constantly evolve to stay ahead of new dangers, even moving from the open ocean to a completely different fight. You can really see that evolution over time. It was first deployed in 1980, then in 88, it got an upgrade to handle faster Soviet missiles. In 99, the Block 1B version added an infrared camera, a FLIR, to help it spot things like small boats. And then, in 2005, its whole mission changed when the CRAM version was sent to Iraq. And here you go, you can see that evolution perfectly. On the left, you've got the classic naval Phalanx, and on the right, the land-based Centurion CRAM system. It's the exact same robotic brain and gun, just bolted to a trailer instead of a ship, tasked with shooting down rockets and mortars instead of anti-ship missiles. But there's a really crucial difference you might not think about: the bullets. The naval version uses these super dense, armor-piercing tungsten rounds designed to just shred a missile. The CRAM, though, it fires high explosive rounds that blow up on impact. And, this is key, if they miss, they self-destruct in midair. You obviously don't want those falling back down on your own base.
So, an automated weapon sounds fantastic in theory, but in the pure chaos of real combat, the story of the Phalanx gets a lot more complicated. It's a story filled with successes, but also tragic failures and some really infamous accidents. This is the USS Stark in 1987. An Iraqi jet fired 2 missiles at the frigate, and tragically, its Phalanx system was set to standby mode. It never fired. 37 American sailors lost their lives. It was just a devastating lesson on why these systems have to be on and ready at all times.
Then you have the problem of friendly fire. During the 1991 Gulf War, the battleship USS Missouri fired off chaff, basically a big cloud of aluminum strips meant to confuse radar, to defend against Iraqi missiles. Well, the Phalanx on the nearby USS Jarrett, which was in full auto mode, saw that cloud of chaff, identified it as a threat, locked on, and fired a burst that hit the Missouri. It's a stark reminder that the machine, well, it can't tell friend from foe.
So it's a really mixed record, isn't it? You have the Stark incident, which was a failure to even engage. The Missouri incident was a case of mistaken identity. Then, in 1996, a Japanese Phalanx accidentally shot down a U.S. Navy jet during a training exercise. But just recently, in 2024, the USS Gravely made history when its Phalanx successfully shot down an incoming Houthi missile, its first ever combat kill of that kind. So, despite this complicated history, the Phalanx has become an absolutely vital piece of defensive tech for militaries all over the globe, proving its worth time and again on both land and sea. And its success on land is just undeniable. By 2008, the CRAM version had already defeated over 100 rocket and mortar attacks against U.S. bases in Iraq. I mean, it became an incredibly effective shield for troops on the ground. Just look at this map. From the Americas to Europe, the Middle East, all across Asia, the Phalanx has been adopted by over 15 different navies. It really shows you just how widespread this American-made defense system has become. And inside the U.S. Navy, it is everywhere. For more than 4 decades now, the Phalanx has been a standard feature on pretty much every surface warship, just standing there, a silent, ever-watchful guardian. So what's the big takeaway here? Well, from its beginning as a ship's absolute last hope, the Phalanx has evolved into one of the most significant and adaptable automated defense systems ever built. But all of this technology leaves us with a really difficult question. As we hand over more and more of these life and death decisions to machines that can react faster than we can even think, who's really in control? And when that autonomous weapon makes a mistake, who's the one who bears the final responsibility?